We measured a great dataset of this tungsten iodide cluster material on our Crystal Synergy-S with molybdenum radiation and HyPix 6000 HES detector. However, the residual electron density map is a bit high due to absorption effects of the material. We can take care of this by doing numerical absorption correction, and for numerical absorption correction we need to have the shape of our crystal and its orientation in the X-ray beam during the measurement. We can index the crystal facets simply by dragging and double-clicking along the possible phase normals of our crystal. Once we have the front face of the crystal, we can click on turn 90 to have access to the backside of our crystal, and here we simply draw the thickness of our crystal. Once we have the basic outline of the crystal, we can simply trim off the material that has been indexed too much. As tungsten iodide has a relatively high absorption coefficient, we want to do this as good as possible. After we have the shape of the crystal, we want also to feed in the chemical formula of this material. Click on Edit Formula and import the chemical formula simply from the res file. CrysAlis will read in the chemical formula, the Z factor, and calculate the absorption coefficient mu. Furthermore, we can give qualifiers, intensities, color and shape of the crystal, and Olex will read in all of this in the ZIF file preparation step. Furthermore, the crystal size is calculated based on the shape that we have given. If we go now on Refinalize, on top of the empirical absorption correction, we are doing now also numerical absorption correction. Choosing the second option here, copy HKL, will also copy the newly scaled HKL file into our structure refinement folder. All parameters have improved, may it be I over sigma or I int. If we refine now on this newly scaled HKL, you can see that also the R1 has been drastically improved, so has the residual electron density. We will refine now until no more shift can be observed, and then we can have another look on the residual electron density map. You can see that it has been cleared out much more, and we can even see some distinct features of this halogen bonding. Here's an overview over the different types of absorption corrections one can apply in CrysAlisPro. Empirical absorption correction is applied always automatically to your dataset and works best the higher the redundancy in your dataset is. Numerical absorption correction doesn't need to have high redundancy in the dataset and works best the higher the absorption coefficient is. You see it clearly that empirical and numerical absorption correction combined give you the best scaled dataset.